Today we're going to start Unit 5, and Unit 5 is about polynomials. So there's several types of polynomials, but the first thing we want to do is just kind of look at the assignment sheet for this unit. Okay, so just looking at the assignment sheet for Unit 5, look at our dates here. So we're going to start Unit 5, first lesson on the 30th. We're looking to take the test near the end of December. So basically, the end of December for us is right before Christmas break. So we're looking to take the test right before we break out. So make sure that you do that. Make sure you're keeping up with these videos. And we're going to go ahead and get started because this is a long lesson. Okay? So polynomials can be classified in two different ways. They can be classified by name. They can be classified by degree. And this is just a warm-up. So polynomials with one term are called monomials. Polynomial with one term is called a monomial. Polynomials with two terms is called a binomial. And polynomials with three terms are called trinomials. And then all other polynomials are only called polynomials. So what do these terms look like? So a one-term polynomial would be something like 3x. Two terms would be 4x to the fifth minus 3. Three terms would be 2x squared minus 5x plus 2. Four terms would be x to the sixth minus 3x cubed plus 2x minus 5. Now, that's by name. This is by name. One term, two terms, three terms, and 4 plus terms. But by degree, what we're looking for is this little number. When there's no number, it's like saying x to the 1. This is a 1-degree polynomial. 1 degree. And we refer to this as a linear function. It's a straight line practically. The quadratic, on the other hand, the quadratic has a number that's to the second power, so it's a second degree or a 2-degree polynomial. Similarly, a cubic function is a 3rd degree. It's a cubic. We refer to it as a cubic. This is the behavior of the cubic. Now the quartic function, that's what we call any x to the 4th power. The quartic function is a 4th degree polynomial. And 5th degree is a quintic. It's quintic function. Okay? Things I want you to notice about each of these equations. This is odd. This is the odd function. The number is 1. This is an odd function. This is an odd function. So all of these are odd functions. And odd functions have similar behavior. On one side, they're going to negative infinity. On the other, they're going to positive infinity. But if you notice, with the even function, these are even, in behavior is on the same side. For my even function, in behavior is on the same side. Okay? Now, the great thing about polynomials is that behavior is relevant as you use bigger and bigger numbers. And similarly for the odd function for the cubic, here we're going to negative infinity. On the other side, and behavior is positive. The quintic function, negative infinity on one side, positive infinity on the other. So all polynomials have the same description in some ways. Polynomials are continuous and smooth. And there are two main things about the graphs of polynomials. The graphs are continuous, which means we can draw it without lifting our pencil from the paper. The graphs of polynomials are smooth. There are no sharp corners or cuts. That means the absolute value function is not a polynomial. This weird thing, not a polynomial. That quadratic, the parabola, it is a polynomial. So we're going to look at polynomial functions and the turning points. So we can tell the degree of a polynomial. We can tell the degree of a polynomial by the number of terms. So the number of terms, these are turning points, and I know it's written right there, but turning points, you can find them because they're right here. They're where maximums and minimums occur. Maximums and minimums occur. Okay? Now, if I want to find the maximum number of possible terms in a polynomial, it's always one less than the degree of the polynomial. So if you're confused about what I'm saying, the degree of this polynomial, the biggest x term here is 2. So the degree of this polynomial is 2. That means I'm only going to have n minus 1. I'm going to write n equals 2. So this equals 2 minus 1, or 1. The number of turning points is 1. So when I graph this polynomial, and all you need to do is to go to y equals and put it in your calculator, right? So you have x squared plus x minus 2. And you should get a minimum, or you should get 2 zeros. One's over here, and one is right here. So I create my graph, right? And if I look, there's only one turning point. One turning point. And it's true. That's a quadratic. All right? Now, for the next one, you have negative 2x cubed plus 4x squared plus x minus 2. And when you graph it, well, if I was using this information, n equals 3, the maximum number of turning points, sorry, that should be n minus 1. N minus 1 equals 3 minus 1. The maximum number of turning points should be 2. Doesn't necessarily mean there's 2, but it should be 2. So graphing this equation, I have 3 different zeros here. 3 different zeros. So when I create this, going down, go back up, going down again, and if you look, here's a turning point, and here's a turning point. So for this one, I have 2 turning points. And it looks like it checks out. There's 2 turning points that are maximum number of turning points, but it could be less. It could be less. This is just the maximum possible number of turning points. Now, x to the 4th plus 5x cubed plus 5x squared minus x minus 6. The degree of this polynomial equals 4, so n minus 1. The maximum number of turning points for this function is 3. Now I know they both have the same end behavior, right? So it looks like this graph does something like this. Goes up, comes back down, goes back up to infinity. It still retains the behavior of a quartic function, where the end behavior is infinity on both sides, but there's literally 3 turning points, or 2 minimums, 1 maximum. Add them up together, you get 3 turning points. On the other hand, the next function, let's check it out. We have x to the 4th minus x cubed minus 3x squared plus 5x plus 1. Press trace on my graphing calculator. You haven't done it already. And what you find, your degree is 4. Your n minus 1 equals 4 minus 1. Or at maximum, I'm going to have 3 turning points. It doesn't mean that I have 3 turning points. It just means maximum, I'll have 3 turning points. So this is what the graph looks like. It comes down, goes up, gets constant, and then keeps going back up. So technically, you only have 1 turning point, 1 point here, but the degree of this polynomial is 4. So this is an instance where there are less turning points than the maximum number of turning points. Okay? It's one instance of where there are less turning points than the maximum number of turning points. So how many turning points does each graph have? Well, let's go look. Let's go look and count all the maximums and the minimums. All right? So here's a maximum. This is a maximum. This is a minimum. I see 2 turning points. Okay? Now here's a maximum. Here's a minimum. Here's a maximum. Here's a minimum. 1, 2, 3, 4. I see 4 turning points. So things I can know about this graph right now. This is at least a 3rd degree polynomial. It could be a 5th degree. We don't know yet. The next one is at least a 5th degree polynomial. Now look at these next two. We have a minimum here, a maximum there, a minimum here. This is 3 turning points. This is at least a 4th degree polynomial. Look at the next one. What's crazy? I see up. I see a minimum. I see a maximum. A minimum looks like a maximum. 1, 2, 3, 4. This is 4 turning points. This is at least a 5th degree polynomial. You know how I'm getting these degrees? I'm adding 1 to each one. Now, a special example, number of turning points, there is 0. This is an odd function, and it's at least a 3rd degree polynomial. It's at least a 3rd degree polynomial. Can't be a linear function, because linears are straight lines. Now, we took care of that part, right? Now we're going to do some little sketches here. A little sketch of each function. So this is my linear function. We're going to write the name of it. My linear function. And basically, as we're going to do some little bit of writing. So as I move towards the right, what's happening to the y value? So as I move towards the right, the y value goes to positive infinity. If I move towards the right, I'm going upwards. Now, if I go towards the left, that's what it's asking you. What happens to the y value? They decrease. So I have negative infinity. This is a 1 degree polynomial. Now, for my quadratic, right? Actually, let's do that in black. Right? But for the quadratic, as you move towards the left, what happens? As you move towards the left, y increases towards positive infinity. As you move towards the right, y increases towards positive infinity. So towards the right, I have positive infinity. The left, I have positive infinity. This is a 2 degree polynomial. It's also the quadratic function, quadratic family function. Now, the x cubed function looks a little bit like this. Now, this is my cubic functions. They're cubed. And what's the end behavior like? Well, I said I wanted to do this in black, and I didn't do it. So let me redraw this. Let me redraw that. Okay? Now, the end behavior of the cubic function. So as you move towards the right, so you move towards the right, looks like I'm going to positive infinity. Now, as I move towards the left, y values are going towards negative infinity. And this is a 3-degree polynomial. Now, your quartic function looks like a parabola, except it's a little bit wider. It's my quartic function. Okay? This end behavior, it looks like if you've practiced by now, on the right, where's the right? This is the right. This is going towards the right, towards positive infinity. I'm going up to infinity. On the left, I'm going up to infinity. So the end behavior for even functions, we can conclude, is the same on the left and the right. The end behavior for odd functions is different on opposite ends. Now, for the next one, this is y equals negative x. This is y equals x negative x squared. This is y equals negative x cubed. You're essentially flipping the functions over. And this is y equals negative x to the fourth. So similarly, what happens? Well, as we move to the right, of this function, the y values decrease and we have negative infinity. As we move towards the left, y values increase and we're going towards positive infinity. Okay? Now this is a 1-degree polynomial. This is a 2-degree. This is a 3-degree. And this is a 4th-degree. Okay? Now, in behaviors, for the y equals negative x squared, as they move towards the right, y values are decreasing. As I move towards the left, the y values are decreasing. So here in behavior is negative infinity, negative infinity. Next one, as I move towards the right, y values are decreasing. As I move towards the left, y values are increasing. So left down here is increasing. Right over here is, sorry, I said that wrong. Increasing for the left. Right is decreasing. Now, last one, towards the right, I'm going towards negative infinity. Towards the left, I'm doing towards the same behavior. So negative infinity and negative infinity. So that's the end behavior. And essentially the rules of this are right here. It's the rules right here. So this is for all of my even functions. This is for all of my odd functions. Now, practicing without graphing. First of all, it's negative, so it's going to look like, I'm going to sketch it. Looks like this. It's negative, it's a quadratic, looks like that. That means my end behavior is going towards negative infinity to the left and positive infinity to the right. The degree is 2, this one's 4, this one's 5, this one's 1. The name of these functions, this is a quadratic. Number of possible terms, n minus 1 equals 2 minus 1, or 1. As x goes to the positive side, as we go to the positive side, it's going to infinity, negative infinity. As x goes to the left, it's going to negative infinity. Now, with my other function, it essentially looks like this. Remember, this is a positive. There's a positive in front of this x to the fourth, the biggest x term, so it's going to be shaped up. And it's a, this is a quartic function. And my number of terms is n minus 1, or 4 minus 1, which equals 3. In behaviors, from positive infinity on both sides. For my other function, this is a positive function, so it looks something like this. As I move to the right, as I move towards the right, I'm going towards positive infinity. As I move right, I'm going towards positive infinity. As I move towards the left, I'm going towards negative infinity. All right? This is a quintic function. The number of terms is n minus 1, or 5 minus 1, or 4. The last one is a linear function. Looks like this. And in behaviors, positive infinity towards the left, negative infinity towards the right. Okay? So negative infinity and positive infinity. And there are 0 terms. 1 minus 1 equals 0. All right, so graphical characteristics. We're going to go and graphically characterize this next function, right? So I know that there are 3 turning points. So the least, this is a 4th degree polynomial, right? So the function family, likely classification by degree is 4. The function family is a quartic function. Quartic function, 4th degree polynomial. Domain is negative infinity to positive infinity. My range, I'm looking for the lowest y value, and it's right here at -4. And then this range goes all the way up to positive infinity. So from -4, I'm going to do some green, -4 over to positive infinity. Intervals of increasing. So increasing means I'm headed upwards. So this is my interval of increase. And here's an interval of increase. So we're looking at x values only. So from x values only, from this interval over to this one. So from -2 over to -1. So that's my first interval. So from -2 to -1, and it's hard brackets. Okay? And then from, looks like 0, from 0 over to positive infinity. From 0 to positive infinity, it's increasing. Comma, from 0 to positive infinity. Now, let's look at our intervals of decrease. I'm going to use, let's use a purple. Okay, so intervals of decreasing, and I want to use a highlighter there. So here it's decreasing, here it's decreasing, and here it's decreasing. So intervals of decreasing. So my interval of decreasing, I'm coming from negative infinity. I stop right here at -2, and then start at this number and go over here. And I'm done. So let's do these numbers here. And I said I wanted purple, so I'm going to give myself purple. So from negative infinity over to -2. That's my first interval of decrease, right? So from negative infinity over to -2, hard bracket, comma, from here at -1 over to here at 0. Okay? The asymptotes here, there's none. Now, the zeros, there are some. The zeros, I'm going to erase all of this. The zeros, there are some. I have a 0 here and here. So 2 zeros. I have a 0 just guesstimating between 3 and 2, -3 and -2. So x equals -2.5, comma, looks like 0.5. I'm going to do curly brackets. All right. Number of turning points, I said that there's 3. The x-intercepts, I have -2.5, comma 0. And I have 0.5, comma 0. Y-intercepts, I have 0, comma, negative 1. 0, comma, negative 1. My local maximum is here, and it looks like I have negative 0.75, comma, negative 0.5. My local minimums, I have 2 of them. I have one here. This is negative 2.1, comma, 1, 2, 3, 4, negative 4. And then I have one here, and it looks like 0.25, comma, 1, negative 1. So I write these over here. So negative 2.1, comma, negative 4, and 0.25, comma, negative 1. The end behavior. As I move towards the right, my end behavior, it's going up to positive infinity. As I move towards the left, my end behavior is going towards positive infinity. Now, moving on to transformations. Remember that given f of x equals ax plus h to the nth plus k, if a is negative, flip it over. Okay? Now, things you need to know. Plus h, move left h units. Minus h, move right h units. Now, plus k, you move up k units. Minus k, move down k units. Okay? If it's bigger than 1, if a, the absolute value of a is greater than 1, you stretch a units, and that means you stretch upwards or downwards. You stretch upwards or downwards. Now, if the absolute value of a is less than 1, you shrink left or right, and we'll see what that means. Okay. Now, if I have f of x equals x to the 4th, then my transformation is to reflect, and they put a negative in front. This means reflect over the x-axis. So if I reflect over the x-axis, I retain my vertex, and then this right here, 1, 1 becomes negative 1, negative 1. 1 positive 1 becomes 1 negative 1. Okay? And similarly with the other points. So it flips over, and the new function, f of x equals negative x to the 4th, looks like that. Next, f of x equals x cubed. So what happens? Everything shifts up 2. So moves up. This is my transformation. Moves up 2. So my new vertex, or this new critical point here, moves up 2. And then my new function looks like this. Okay? X to the 5th. So I'm moving right 1 and shifting down 3. So moving right 1, shift down 3. Here's my new vertex. I started here. Then I just make my graph, right? And I'm done. Note the difference between x cubed and x to the 5th graph. So let's look at the difference real quick. Sorry about that, guys. I didn't mean to put the graph up there. So if you notice for x cubed, x to the 5th, the bigger, so this is what I want you to know. The bigger the exponent, typically what we can say about that is the smoother the critical points. So what you'll find, the critical points, I mean here and here. I want you to erase this so you can see it's a little bit steeper here at x cubed. But here it's a little bit wider, it's smoother, it almost looks constant. Similarly with my quadratics, x squared will look something like this, but x to the fourth looks like this. They like widen out at those critical points a little bit. So it's something interesting to note and to be mindful of when you're trying to determine the equation of a graph, right? I'm trying to determine the equation of a graph. So let's see where we're at. We're in about 30 minutes. So I'm going to cut it short there. And that's going to be part 1 of this video because of the length of it. And then we're going to go to part 2.